Hello, I'm Jonghyun Park, a master's degree student in Chungnam Computer Engineering from Chungnam National University. Today, I will talk about how to improve Tor hidden service crawler's performance. Before we start, let me introduce Tor and hidden service. Tor is called a darknet, a kind of deep web. Tor is a special network that supports anonymous communication using onion routing. The figure below shows how Tor uses encrypted packet and P2P nodes to communicate anonymously. Tor's anonymous web service is called the hidden service. They use a special address called onion address rather than IP address or domain name. There are many illegal contents such as hacking, black market, and child pornography that exploits the anonymity of hidden service. There are some difficulties in crawling Tor's hidden service. First, Tor's slow access speed. The red line on the graph is page loading time about surface web. The yellow line on the graph is page loading time about hidden service on Tor. It is 2.5 times slower than surface web. We can see also that the blue line of the graph, the case of the surface web using Tor, is 4 times slower than not using Tor. Second, hidden service is operated in short term. 60% of hidden service were accessible for less than 10 days in 150 days. Third, the number of unique onion address is increasing. This means need to crawling more hidden service pages. The cause of this increase is not only an increase in hidden service, but also an increase in duplicated hidden service using more than one address. Our problem is reducing crawling times of Tor hidden service. There are several challenges in crawling Tor hidden service. Tor access is not allowed in general. So we use cloud instance. We need to manage cloud instance, and we need virtualization and distributed processing for cost and speed. And Tor's hidden service are redundant. Remove duplicated hidden service is a challenge. We use the following methods for problem solving. One is parallelized hidden service crawling through cloud instance, container-based virtualization, and multiple browsers using tabs in the Tor browser. And clustering duplicated hidden service to minimize duplicate page crawling. This picture shows the overall structure of our system. The system consists of 4 main modules. Each module works by sharing Tor data, such as onion address or hidden service page. Now, let me explain some modules that are important in the operation of the system. First, we need to correct onion address in order to crawl Tor's hidden service. But where can we find the onion address of the hidden service? In general, we use a search engine to find web pages. Search keywords and find relevant pages to correct. However, Tor does not have a search engine like Google or Bing. Hidden services are notified via Tor's community or private emails through membership. For this reason, the onion address of hidden service are typically collected manually. We paid attention to a service called Tor2Web. Tor2Web is a proxy service for accessing hidden service on the surface web. Some hidden service use this service to enable access even if you do not use Tor. They use a modified onion address that transforms the top-level domain from the onion address. For example, .onion to .onion.city. Hidden service using Tor2Web can be accessed from the search engine. In other words, we will be able to discover hidden service from the surface web search engine. We collected some top-level domains generated by Tor2Web in the table from the Tor community or hidden service link directory, and search them as shown below to collect modified onion address. This onion address are the seed onion addresses, restoring the top-level domain to its original form. This is done in a module called Tor Onion Address Collector in our system. Now we are ready to crawling hidden service. We need to some preparation to crawl hidden service. Set up the proxy, open the port, run Tor, and connect the browser or crawler to Tor. These preparations for crawling hidden service are complex. We simplify this process. The Tor project is deploying a Tor browser, a standalone browser for using Tor. The crawler is ready to collect Tor by simply launching the Tor browser through Selenium. The Tor browser will run the built-in Tor depending on the preset. So, if we run 2 or more Tor browsers, there will be a port collision with 2 or more Tors running. For this reason, typically only one Tor browser runs on one operation system. We introduce container-based virtualization for a simple solution to this problem. Container-based virtualization creates independent containers above the operation system. Each container can have a separated OS environment. Also, deploy container images to easily replicate the same work environment. Our system runs multiple containers on one operation system and run the Tor browser and crawler in each container. Because containers share the resource of a single computer, can maximize the use of computing power. Selenium supports JavaScript function to open new tabs. We take advantage of the fact that it is not possible to run more than one Tor browser, but multiple browsing is possible using tabs in the browser. Selenium-based crawlers access pages directly and store open pages. We access and crawl multiple onion addresses at once using multiple tabs to crawl many pages at once. The result of the following experiment showed that using a Docker-based Tor crawler can reduce crawling time. We compare the crawling time for 100 sample onion addresses. We were able to shorten the crawling time from up to 8 minutes to 9 minutes. Using one browser, crawling time was shortened from 50% in 2 containers, 70% in 3, to 79% in 5 containers. Page collection rate from up to 3 pages to 13 pages. This increased linearly with the number of containers. The following is the structure of Tor Hidden Service Analyzer. This module consists of a page similarity analyzer and onion address extractor. It updates the onion address set for the next crawling. Hidden service using more than one onion addresses. In Tor slow access speed, duplicate page collection is a big waste. Page similarity analyzer clustering duplicated hidden service to collect only representative onion addresses. The analyzer uses a cosine similarity calculation module to find duplicated hidden service, converts the text of two hidden service into a word vector to calculate the similarity. It also uses the HTTP response header comparison module. If both hidden services use the same server, it can be assumed to return the same response header. The following figure shows the HTTP response header returned by hidden service with different onion addresses. The format of the HTTP response header differs for each server, and you can see several headers of the same type. We can guess that some hidden services are running on the same server. This module complements low cosine similarity due to multilingual service and product price difference. The clustering results were as follows. We set the threshold for cosine similarity to 80% and the threshold for HTTP response header to 90%. 21% of onion addresses are clustered from 2527 to 2014. Crawling time also reduced by 39% from 713 minutes to 433 minutes. We introduced the Tor onion address corrector in the front. However, this corrector can correct only the onion address of hidden service using Tor to web. Many hidden services do not use Tor to web, but advertise only in Tor. The onion addresses of these hidden services are found in the internal links of the dark web. Many hidden services onion address extractor find new onion address from dark web. HTML link parsing module find new onion address from the corrected hidden service pages. Onion address consists of 16 random alphanumeric characters. Therefore, HTML link parsing module can use the regular expression to find the onion address. We use this regular expression. Finally, we check the contents and dynamics of the hidden service. From January to May 2018, we collected 25,261 unique onion address and 2,527 unique hidden service. We manually categorize the contents for 722 hidden service. Illegal hidden service includes all categories except legal hidden service and unknown. They account for 42% of the total, which means that illegal hidden service are operating as much as the legal hidden service. Legal hidden service includes marketplace, personal blog, and server hosting service. They account for 43% of the total. In order to analyze the dynamics of hidden service, we counted the accessible date from January to May. 52% hidden service is below the life expectancy of the typical web of 100 days. Only 7% of hidden service are always accessible, and 32% operating long-term service over 145 days. 7% of the hidden service were short-term service, operating under 7 days. Our study is summarized as follows. We were able to shorten the crawling time by up to 79% through the Docker-based Tor crawlers. Clustering onion addresses for duplicated hidden service reduced 21% of unique onion addresses and reduced crawling time by 39%. As a result of the analysis of the hidden service, they have a different environment from the normal web. There are various illegal hidden services in Tor, and it is difficult to access at all times due to irregular operation. I have finished my presentation now. Thank you.